Hello and welcome back to Classic Arcade Repairs, everybody. My name is Sean, and today we're going to be looking at a Breakout by Atari 1976. This one's all TTL, no CPU on this guy, and it's a little nasty, a little on the nasty side. See, it's all pitted, corroded a little bit. I'm going to wash this thing, spray it down with some simple green, and see if that'll make it look better. Anyway, clean it up. Before I do anything, I'm going to remove this wire. I'm going to remove that for now, as I don't want that in my way while I work on this. I'm going to get this working as it originally did with the original power and everything. If you look at the wiring diagram here, you'll see up here transformer 01551. So I just happen to have right here a transistor or transformer 01551. So I have this very transformer right here that is right here. So I'm going to use that to power the board, and we'll go from there. I'm going to have to make a wiring harness for this guy, but first things first, I'm going to wash it up. First thing, somebody has recapped this thing. It's got all new caps, which is nice. I don't have to mess with caps. And the two power diodes up here have been replaced, so I don't have to mess with that. So let's go ahead and get this thing cleaned up, hopefully shine it up a little bit, and yeah, we'll go from there. And my Breakout harness is complete. As with a lot of really early Atari stuff, the coin switches, actually, the circuit goes out into the cabinet. It leaves the board and it's completed in the cabinet with the switches. You have to have both normally open and normally closed connected on both switch 1 and 2. Actually, I don't know if you need switch 2, but you definitely need switch 1. That stuff can't be floating, so you have to connect that. Yeah, so that's done. The harness is done. So we will let's hook this board up and see what we do. Monitor power first thing. Well, actually, first thing is I have to do some edge repair on this board. The edge connector was pretty bad, so I'm going to have to do a little bit of repair work. So let's go ahead and do that. Okay, and the trace repair is done. This is top side. It's just these two traces here. They both wrap around. The first two over here, these two guys right here are ground. These two are ACN. So you got ground and ACN, and both of them burned up. If I turn it over, you'll see what I did on the repair here. This one just terminates right. That one just terminates at this pad. This one went all the way up and around here. So what I did was I ran the tape up, and I just kind of tinned the tape up to there. That was all pulled up. That whole trace was pulled up where I've got that copper pad, that copper tape. The whole thing was missing. So now our edge is looking pretty good. Now we can go ahead and get ready to fire this baby up. Now, I did wash this board, and it did come a lot cleaner. But there's just some old, 45-year-old corrosion on there that's just not gonna come off. So it's as good as it's gonna get. But it'll be good enough. So we'll go ahead and fire this thing up and see if it does anything. Okay, we are hooked up here. We got parts to parts, power, we're ready to monitor power. Let's go ahead and fire it up. 4.93, we're good on 5 volts. And it's doing something. It don't look like it's doing a whole lot. Is that a vertical hold issue or something? Let's try to mess with some pots back here. It's brightness. Yeah, I just think that's flakiness. It's not really doing much of anything, I don't think. Huh. I believe what I'm going to do with this guy is just, since it's all TTL, the whole thing is TTL, I think I'm just going to start poking around. You know? Breakout. I need to see this game. I need to see what it's supposed to look like. I think I'll do a little research. What is this thing supposed to look like? It's definitely got some funkiness going on. Well, this switch is doing a little something. I'm messing with this switch. Uh-oh. That switch really goofs it up. This one doesn't seem to do anything. This one really goofs it up. And this one just was doing a little bit, now it's not. Yeah, she just dead. Alright. I'm going to do a little research. I might read some of this. Has theory. There's a, the manual has theory of operation, so I'll probably read up on that a little bit. Check this thing out. Ooh, ow, ow, ow. Is that a prom chip? That is a 7474. That is a flip-flop that's way too hot for a flip-flop. Yeah, I'm gonna do a little research to kind of study up a little bit. I want to see what this looks like. I want to pull it up on YouTube or something and check it out, see what it looks like. So we'll be back. Alright guys, well right off the bat, this 74, that is way too hot for a flip-flop. Hot britches flip-flop here. This is preset, which is doing a little bit of weird. I mean, it don't look good, but it's doing something. This is going to be your data. Data is just tied high. Let me move this. Let me get this out of the way a little bit. Get a little bit better, okay? Where were we? This is data, tied high. Then this is your clock signal, which, you know, does not look great at all. Everything looks like it's lifted up a little bit. You see how it's, the offset is, it's offset a little bit. Everything's pulled a little high. This is the clear, pin or the preset. I'm not sure which is preset, which is clear. They're both high, so this thing just runs. This is Q and Q naught. That thing's definitely no good. She definitely bad. So there's one. I'm going to go ahead and just red dot these things. I'm going to just poke around this board and red dot stuff. Man, that is hot. Yeah. Yep, that's what I'm going to do without without looking at schematics or anything. I'm just going to red dot stuff. I'm going to poke around, find the obvious stuff and just red dot it. Even before I look at any kind of theory or anything about this. It's bound to just have bad stuff on it. So let's do that. I'll be back. I'll be back, guys, with probably a bunch of red dots on this thing. Okay. I'm going to do some poking around on this thing and kind of let you follow along. I'll let you know what I am looking at, what kind of a chip I'm looking at. So far I found, let me count the red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 red dots so far. Alrighty, let's take a look. Let's look around, poke around a little bit. Alright, this is it's labeled 9316, which is it's a 161 counter. This is the clear signal, which is low all the time. Oh, I gotta turn the let me turn the game on. Okay, it's on. And there is our clear signal, which is high. Let's look at these enables. This is low. So this thing will not count with this. No, it's high and it's low. Okay, this is going high and low. That's the load pin. And this is pin 10. Okay, so this is the clock, and there's no clock. No clock. Moving on. Okay, here's a 7474 flip-flop. This is preset, which is low, which means Q should be 1 all the time. And it's not. Preset is low all the time, so Q should be set to 1 all the time. That overrides. Your data's low. There's no clock. This is clear. This is the clear signal. Unless 1 is... it shouldn't matter. This is always low. And this is clear or preset. I'm not sure which one it is. Well, this is Q. Q's doing this, and Q bar is doing this. That's supposed to be the inverse of Q. This thing ain't working right. It's not doing anything really. This is the other side of it. Preset is high. That's data. There's your clock signal, which is not doing anything. And that's clear. Q. Q and Q bar. So this has to be, no. Now these are both high. Data's low, so Q is low. That seems to be working on that side. This board is a disaster. I don't think that there's any saving this board. Here's another 74 flip-flop. It's preset. Data is high. Clock. No clock. And no clock. That's, you know, Q and Q bar. Data. No clock. No clear. High. Low. 7400 input. Hey, finally a good looking signal. Okay, that's an input. There's an input. And a good looking output. Input. Input. Output. Input. Input and output. Input. Input. Output. That chip actually looks pretty good. One of the best looking chips I've done so far from this board. Okay, and let's do 7408 AND gate. Input, input, in, out. Input, input, out. That actually looks good. In, wait a second. Input, input, out, okay. In, out. Okay, that chip looks pretty darn good. $7411. Input, 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 output. In, out, and in, out. That one looks pretty good. Okay. Here's another 7411. There's an input, 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 output, couple low all the time inputs, in, that does not look good. It's not driving low all the way. In and out. Okay. In and out. Okay, it looked decent. That one input was bad. It didn't look good. This is an LS86. This is buffering. That's a bad output. That's an input, and then the buffering input. So you got a high and a signal, and then this signal just doesn't drive low all the way. It's like its reference is too high. I don't like that. That needs to be replaced. And here's another 86. There's your buffered input, your buffering input, and then you got a floating input. Yeah, that's just a floating input. So your output is low. Input. Low. That's a bad output. Yeah, that's definitely no good. So that one's got to be replaced. And here's another 86. That is input. That's not good. That's your output. There's your input. There it is. High. There's your buffer. There's your input. And your output. That looks okay. Buffering input. Your input. And your output. Looks good. In. Nice signal. Nice signal out. Come on. Okay, there's your input. Input. Output. That chip looks to be okay. Okay. Here's another counter. And then there's your clock on this counter. And the clear signal is floating. That's the clear signal. That's the clock. That's the clear signal. Here's your inputs. Got high input, high input, high input, and high input. This is pin 7, the enable. Pin 9, the load. Pin 10, an enable. And your counts. The counts actually look good. And that's pin 15, that's your carry bit. This thing actually looks pretty good. Actually looks like it's doing something. Oh, what a disaster of a board. What an absolute disaster of a board. Alrighty, I'm going to take a break for a little bit, and then I'll probably do some more probing around off camera. Alright guys, well, I've been poking around on this thing, just going around and looking at chips, finding bad stuff. So far, let's count. Red dots are bad. And white dots it looks good, the chips look good. That does not mean that they are good, because I have not analyzed any of the signals. But at least they have signals and they look halfway decent. But the red ones are definitely bad. So let's count the red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 so far. Yay. I don't know about this one. I think I might call it quits on this one. It's just too far gone. It's too bad. Look, it's on there. You know, it's got picture on the screen doing something. It's a shame. It's kind of a goofy, wavy ass picture. And this one right here, I believe, is in the either horizontal or vertical count, and one of them's funky. But look at all of this. I mean, I don't know. I mean, valiant effort by someone by capping it. But this was a lot deeper than just caps. You know. Don't know if I'm going forward on this one, guys. But I'll think about it. Not for the standard quoted price. That I can guarantee. So this one may be done right here. And if it is, I'll post it as a non-repair. But I got to get a hold of the owner of this board and give him the bad news that it ain't looking good. Man, this thing is bowed. Yeah. So, all right, we'll see what happens. All right, guys, we're going to take another peek at this guy right here. This is that Breakout board, which, if you remember, I had, I don't know if you do remember, I had 21 red dotted bad chips on this board. There's, count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And there might be more because some of these don't have markings on them, so I can't test them. Like these, I don't know what they are. I have to look at the schematic and find out what these chips are before I can really test them to find out if they're good or not. So there might be more than 21. But and another thing that I did to this board, if you're noticing, it looked better, Does it look better? I bathed this thing 3 treatments in toilet bowl cleaner. It was so corroded and just had that nasty film of nastiness on this board. I did 3 treatments with toilet bowl cleaner to wash away that corrosion off this board. I got a lot of it off and it looks way better. The board looks so much better. You can actually see the traces, you know. But anyway, I had contacted the owner of this and I gave him the bad news about how bad this board is, and it's, you know, unfortunately I would not be able to do it for my standard fee that I charged quoted for this, because of, you know, and I left it up to him if he wanted me to move ahead with it, and he didn't. You know, at first he said, no, you know, let's just put it aside and not worry about it. And I was like, okay, you know. Well, he got with me later on in the day, today, and said, hey, let's move ahead with this board. And you know what, I'm excited, because I really want to bring this board back to life. You know, it's in good shape now. It's decent. The back of it is in really nice shape. The back of it is really clean. You know, it's got a couple marks right here. That's just like funkiness from soldering. Someone soldered caps, you know, replace these caps. That'll just brush right off. But it's not in bad shape. And I just got done fixing Time Pilot. Time Pilot's doing a burn-in. And I'm already chomping at the bit to get to this guy. But I'm going to let Time Pilot run for at least 3 hours before I dive back into this guy. But yeah, we agreed on an adjusted fee, and we're moving forward, and I couldn't be happier. So sweet. We will be back. Alright guys, I've been working on this breakout board here. I removed all of the chips that I had tested and deemed to be no good. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 chips. Removed. And I got my list here of what is what. I went through and I the positions and the type of chip it is, and I wrote them all down, and I was like, I'm just going to remove them all one shot. And you know what, for as old as this board is and as crusty and corroded as this side was, these desoldered so easy. It was absolutely no problem. It was quick. Yeah. Okay, well, I guess next thing to do is repopulate. So I'll get to that tomorrow. I'm done for the night. I've done enough. So we'll be back tomorrow. And just for giggles, guys, I'm going through with my chip tester with all these bad chips. I've already done 3 of them and they're not found. I'm just popping them in here and pushing the button. And if they're found, it'll come up. Not found. Dead. Not found. Dead. That one's got a broken leg. Or this one right here was the one that had the wire soldered to it. It's got a leg broke off. So this is an 86. Not found. Dead. This is an 02. Not found. Dead. This is another 86. Get down in there. I gotta straighten a leg or something. Okay. Ooh, LS86. That one was actually good. I know some of these I marked them bad, even if they looked, even if they looked a little suspect. I marked them bad. Not found. That's a 161. This is a 04. Ooh, it's good. This is, I don't even know what this is. I can't read it. Not found. Some of them, like, they were actually doing something, but the signals just didn't look good. I am not going to reuse these ones that said it looked good. This is an 86. Not found. 02. Not found. 74. A lot of dead flip-flops on this board. Dead. And this is another 04. Not found. Dead. This is a 00. Not found. Dead. This is a 161. Count. Dead. 00. Dead. Another 161. Dead. It's amazing this game actually did anything on the screen. This is a 74, a 08, and the gate. And it is dead. This is another counter, another 161. And you're dead. And here we have a 74, another flip-flop. Dead. Here we have another another counter, another 90. There are 93 16s in this board. That is actually just a 161. Same thing. But they're marked 9316. And it's dead. And here we have another 74. Dead. So two of these guys actually tested good. But like I said, I know that there were probably these two chips right here that actually half-ass worked, and it'll probably pass in this. Like one of the 86s, I'm telling you, I know right now this has got to be the one. One of the outputs was half-ass floating, but it was a square wave, but it was a float. It was offset up. It was offset high. So that's probably that flip-flop, or that 86. But yeah, 23 technically bad chips, but really 25 bad chips. Isn't that crazy? 25 of them, guys. All right. So we will we'll get to populating that tomorrow and see what happens. Now there are some other types of chips on here. There's a there's like a row of 8-line to 1 mucks. There's like 6 of them in a row. I probed the outputs, and the outputs, there's complementary outputs. It's the same thing as a 151 functionality wise, but it's a different pinout. But luckily, I probed only the outputs, the 2 complementary outputs I probed, and they looked good. The outputs looked okay. That does not mean that it's okay, but at least they looked good. But if one of those are dead, and I couldn't find any of those online, it's like a 9312 is the number. It's actually the same thing. It's an 8-line to 1 decoder. Same functionality exactly as a 74LS 151, but it's just a different pinout. So if one of those or one or more are bad, I'm going to have to use a 151 and just rig it somehow, you know. Yeah, that'll be interesting. But hopefully they're all good. They looked good. But yeah, so we'll see. But we should get a lot better results replacing all of that junk. So, all right, we'll see you tomorrow. We'll be back, and tomorrow will be exciting because we're going to repopulate this thing and see what it does. See you then. Yeah, before I do call it a night, I wanted to go and just kind of say that the way that I'm doing this is I went through simple gate stuff, easy stuff, and eliminate, you know, flip-flops, gates, that kind of thing. Found all that bad junk. A lot of this stuff well, basically, like some of this stuff, like some of these counters down here didn't have outputs, but I couldn't tell if they were good or not. There's more counters and stuff down here and on the board in other places that I just couldn't really tell if they were good or bad because situation did not dictate that they would have an output. Like a lot of them were just high or low on the outputs. So what I needed to do is get all of this junk replaced so that I get good signals going on this board. Then I can further troubleshoot once I've got good signals going to these chips. You know, and then I'll be able to probe these and see, okay. And you know another thing that's weird that I don't like about this that I'm going to modify is the clear pins on the 161s. They did not pull high. They left them floating. So every one of those 161s that they did not pull high, I'm going to pull high with a 1K resistor. Every one of them. I'll solder a 1K resistor right over top of the chip over to power. Pin 1 to power. Because I don't like that, leaving it floating like that. No. Let's pull it high so that it don't clear ever. If it's not supposed to clear, let's make sure it don't clear. You know, shouldn't leave them floating. I don't know why they did that. But, yeah, it's weird. So we'll go through and mod that, make that change, and yeah, so, alright guys, have a good night. See you tomorrow. Alright guys, this thing has been repopulated. There. All over the place. All those 25 chips. So now I'm ready to fire this thing up and we'll see what we get. I imagine that there'll probably be some issues still, but we'll really be able to pinpoint those issues now that we've got good logic on the board. So let's go ahead and fire it up. And it is on. And it is definitely doing something different. I think we need to, let me mess with the, let me come back. I'm going to mess with the vertical hold really quick. Okay, we're getting somewhere. But you know what? I don't remember wiring audio. I got to check that. But it's still looking a little weird. I think we got, I don't know, some kind of issue here, but it's not bad. We're a lot further. Let's put it that way. But it looks like we still got some work to do. But we're getting there. So I'm going to do a little research on whether I wired up audio or not. I think I did. How the audio works, I don't see an amplifier on here. I wonder if this was one of those things where it's externally amplified. It probably is. So, okay. Alright, I'll be back, guys. Okay, as you can see, we've got some issues to work on. This is our paddle is good over here, and then it freaks out over here. So, and I had to actually wire in a serve button, and you'll see we got issues with this too. It'll serve, and boy does it break out. It just breaks right through there. There's no stopping that ball. Yeah, so we got some problems, but the game is actually playing, which is incredible. It is actually playing. There's no sound. I'm going to have to order sound amp is LM380. Nope, the sound amp is fine. So we're just not, we don't have sound. We have sound failure someplace. So that should be easy to find. But the amp seems to be fine. So, well, we got to figure this paddle out. It's crazy over here, but it's good over here. But over here, just I'm going crazy. I can't help it. I'm going crazy. And then the ball, you serve, and the thing just goes right through there. Boom. Breakout. Breakout. All right. Well, I'm going to do a little probing around. I'm going to look at the schematic. What do we want to do first? I don't even know. Let's try to fix the paddle first. Let's concentrate on the paddle circuitry, and I might have to buy some parts for this because I was looking at the schematic a little bit, and there is an integrated circuit which is an SR latch in a package. It's an LS, or it's actually a 74279, and there's a slew of those things used on this board, and I don't have any of those. I've never encountered a system that uses that chip. So it must be really old school. So I might have to buy some of those. I think they're used in that circuit. But yeah, I'm gonna just I'm gonna poke around the paddle circuitry and see if I can't figure that out. Okay, this timer is in the paddle circuitry. And I'm looking at this capacitor across pin 5 that I believe is a $100. It's across pin 5, and then you have a 0.01 right here, which I believe is across pin 5 as well. And it looks like we have a purple, black, I don't know what that is, yellow, purple. We have a resistor going from a 74, that's a 74, no, that's a 4066. 4066 has a resistor starting with 4 going to pin 6. Let's go look at the schematic. Man, we come over here and we get to our schematic. So we had a resistor from an 04 going to pin 5 or something, 6 or something like that. I don't remember. I already don't remember. But we have a 0.01. There's our 0.01 going from ground to pin 5. And we also have a 1 microfarad capacitor, which is this guy, which is going from ground to pin 5. It's in the wrong spot. That's supposed to be going to pin 7 and 6. So I'm going to take that 1 microfarad capacitor right there, and I am going to move that positive lead to pin 6. And I bet you the paddle works properly. Okie dokie. Well, the paddle has completely disappeared. Completely disappeared. But one thing that I had noticed, anyway though, if I'm not going to be able to do this, but now that I have this in the right spot, and you look at, you know what, I don't have, I got to set this way slow. Anyway, what I was getting at is this LS30 right here is like a 10 input or something, like 8 input AND gate or NAND gate. Anyway, this is the output. The output is floating. So I'm going to replace this chip right here, and that I'll show you what that does. That's an LS30. It is right there, paddle enable. It gets all of these. It looks like 1, 2, and 3 are pulled high. No. Nope, it looks like 2 is pulled high and maybe 3. It's hard to tell. 5, 6, 11, and 4, and 1 are all going to be, regular good old signals. So it looks like 2 and 3 may be pulled high. 5, 6, 11, 4, 1. Let's go look at this thing. But the output on pin 8 right there is the one that you see is just completely floating out there. So maybe fixing that capacitor on that 555 just made the, you know, exposed this. I don't know. But anyway, let's go take a look at all these inputs. Let's look at 5.6, 4.56, 11.12, 1. 4.56, 11.12, and 1. 4.56, 11.12, and 1. Let's see what they look like. 4.56, 11.12, and 1. Here's 1. Right there's 1. There's 4, 5, 6, 8, 9, 10, 11, 12, and the other ones 2 and 3 I believe were pulled high. Yep. And there's your output. Garbage output. So I am going to go ahead and replace the LS30 right there, and we'll see what that does. Alright, got the LS30 in the board, and this ground pin folded up on me, so I soldered the heck out of it to ground it. It folded. Didn't go through the hole, it folded. So I soldered it good, it's in there. But now if we look at the output on that guy, you see it's a nice nice signal, nice enable pulse, and better yet, our paddle is back in action, and even better yet, it is silky smooth. It's not quite silky smooth over there. Huh. It's a lot better than it was, but it's still not perfect. We'll have to figure that out. And we will. Alright, so I'm gonna check out the you know what we have here is a 4066 that is socketed, that is used in the paddle circuitry, so I could really easily just swap a new one in there and see if it smooths it out. So I'm gonna go ahead and do that, see if that smooths out our jagged, our little bit of a flaky movement on that thing. Alright guys, I got to poking around a little bit on here, and I came to this C2, and I poked around and I found this signal right here, looking like, just looks like crap. And I was like, what is this? So I was like, what is this chip? I can't read it, you know, it's kind of rubbed off. So I looked it up on the schematic, and it is a 7400. That is an input leg, which is also connected to this 555. So I was like, okay, what is that signal? The signal is called not attract. And I found out that not attract is used all over this board. These are all of the chips and pins that use that not attract signal. And it looks like that. It just looks like crap. That is supposed to be a TTL signal. So I was like, okay, I gotta find out where that comes from. And I did. It comes off of C6. It's a 74, and it makes attract and not attract. C6. C6. It's this guy, which I've replaced. That's that signal right there. Something is corrupting this. So I'm going to look at the schematic again. I'm going to look at this chip a little closer and find out what is going on around this guy, because I know this chip is good. And I'm going to tell you right now, that is connected to a bunch of these guys. 9602, which is some weird chip. I don't even know. But you can get them at Jameco Electronics, and I'm going to. Well, there's about 4 of them. This guy, 1, 2, 3, 4, 5, 6, 7 pins are connected to that signal. Not including this guy. So something is corrupting that. I'm going to have to figure that one out. So let me poke around a little bit, and I will be back. Okay, around this guy right here, this 7408 right next door does a little bit of business with this thing. And just kind of looking at it, it's an AND gate. So low, low should be low, but it's floating. See, it's floating. You got a signal, a high, so it should just be a square. It should just look just like this. But instead it looks like that. See how it's half-ass floating? It's another one of those half-floating parts. Low, 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 but it's floating. So this guy's no good. So we're going to replace that guy. And I just happen to notice that that's bad. I don't think that that's going to fix this problem, but that's definitely a problem. So it's one of the problems. I think that one of these 9602 parts that is connected to this signal is corrupting it. That's what I think. So I'm going to replace this, and then I'm going to look at it again. And I'm going to start clipping these pins. So I'm going to get to changing this guy, and we'll be back. Alright, got a little good news. This guy up here, the 4066, is not supposed to be a 4066. It's supposed to be a 4016. I just caught it on the schematic. So I put a 4016 in there, and now when I move the paddle, nice and smooth all the way. So that was that. Wrong chip. And I found a 7474 right there. That is no good. I'll show you. I'm getting ready to desolder it right now. You got a high input. This is your data. There's no clock. I think the clock happens in some event. And that's high. And that's your output on Q. And that's Q bar, Q naught. So this thing, and this is the other output, and the other outputs. So this thing ain't doing much of anything. It's a 74. So I'm getting ready to replace that guy right now. So we're getting somewhere. Be right back. Okay, replaced that flip-flop, and it now does look good. The signal looks correct. Okay, we got our paddle working really good. I'm going to serve, and you'll see it's still, boom, indestructible. At least serve is working. That's cool. Alright. Still got some work to do. I tell you, I still have that goofy looking signal. I'll show you. Yeah, we're fixing one thing at a time, you know. We are. But I still got that goofy looking signal right here. We've got to figure that signal out. And I think some of these chips that don't have, like this guy, well no, some of these that look like the writing is burnt off of it. I need to know what those are so that I can test them. But these 9602s are a problem, I believe. And I think I might just go about and remove them all. You know. These 86s. I need to check those again, and the 08s. All these that I checked with white, I need to recheck those. I think I'm going to stop and do that because now they've probably got proper signals going to them. So I need to re-verify these white paint marks. So I think that's what I'm going to do right now. So let me handle that and I'll be right back. Alright guys, I have found a couple more baddies. This is a 7404, and right here is the gate that I'm looking at in that chip, which provides a signal to this RAM. 3 out to 4, and I'll show you that. I broke out the good scope, my good scope. 3, and let me move this so you can get a look at it. 3, you see that little downward spike, and then 4, there should be an upward spike, and there's nothing. And just 1 out to 2 on that same chip. Here's pin 1, and pin 2 looks like crap. I mean, that would work, but I don't like that. But the chip's no good anyway. And then we got a 193 right up here. And one of the outputs, you see there's these 2 output legs right here. And one of them is floating. So I'm going to replace a 193 and a 04. And unfortunately this RAM, 8216, 82S16, right here. It's right here, and the output is on pin 6. See that output on 6? If I probe pin 6 of this guy, 1, 2, 3, 4, 5, 6, check it out. That is no good. So I'm going to have to come up with one of these. (82S16). Huh. Okay. Well, I'll be back. I'm going to replace these 2 chips. And I think I'm going to jump online and check into these, see if there's any available. That is all in this. It's Playfield Brick Hit Set Bricks. All display. I don't know what it does. Looks like it might be involved in, remember how the ball just goes right up through the bricks? You know, this output comes and does some business in here and ends up being brick hit or not brick hit. So maybe that's got something to do with that. Nonetheless, it's no good. So, yeah. Alright. I will be back. Okay, I've been doing some more probing around, and this guy is a, I don't know. I don't know what I did with my paper. I had it. Alright, well, that's a 00, and that's a 555, and I have decided to just replace them because that has that little like that. That's an input from this. So I'm figuring maybe this thing's a little funky or whatever. I don't know. But I'm going to replace both of these guys. You know what? I think I'll just... I'll replace this one first. This is a 32 maybe? This was the reason why I wanted to replace this one. It's just got a low output. You know, this is a full, this is 4.4 volt basically. And then this one is only reading about 3.4. So I'm going to replace that chip. Just to bring that up. That's a 32. And I'm just going to write 32 on it. So we'll get a 32, and I'm going to write 0, 0 on that. Alright, so those, that's a 555, that's obvious. This guy right here is a 7448. On the schematic, it's right here. And you'll see it gets inputs from this business on pins 1, 2, 6, and 7. Those are the inputs. 1, 2, 6, and 7 with control on 5. And we can look at that. 1. Here's pin 1. Here's pin 2. 6 and 7 with control on 5. 1, 2, 3, 4, 5. Alright, and then basically every other bit is an output. So we got pin 3, which is that. Here's pin 15, 14, 13, 12, 11, 10, and 9. So that's a whole lot of outputs from this guy right here that's feeding all of this logic. And I'd have to find the second part to this to find out what exactly that is doing. Yeah, but there's a whole slew of missing inputs there to drive this stuff. So, and I have ordered that. I've ordered a few of them. It's a pretty rare, just a oddball part, 7448. I also have a 160 right here that I've found out is bad. And that on the schematic, I'm not going to be able to find it amongst this mess. I don't know. I don't think so. Nope, I can't find it. But how this works is this is the start. This is like player 2 count. This is player 1. This only will count when player 2 is going. This is player 1. That's only cocktail mode, by the way. These are the player 1. It's I'd have to find it on the schematic again to find out exactly what it does. But this is where it starts, and it starts with basically, it's the horizontal count. I can dial it in just a little bit more. There you go. See, that's your 15.9. Horizontal count. This is that's reset. It's not resetting, and your enable pulses and your loads are all high, so this thing will just run and count freely. There's the first bit, second, third, fourth, with a carry bit which goes and enables the next guy, this one right here on pin 10. So that carry bit goes on over and enables this on pin 10, and it does not have a load pulse, and it is, the other enable is enabled. So this thing has the same clock, but it's second in command. It's second in the chain, and it should count, and it does not count. And in contrast, if I take this 160 right here and put it over that and probe the first bit, you'll see that it does count. So I am going to replace this guy too. And I got parts coming in the mail. I've ordered all those 93 or 9602 parts. I've ordered the 48. I bought a bunch of these RAMs, though this RAM is not bad. Pin 6. Even though it looks like that, it's just a it's got to be tri-stated and then going high and low, because all this does is make the brick display. So I'm thinking that it is a tri-stated part, and it's going low and high from a tri-stated position, is what I believe, because it seems to work just fine. The bricks are right there. If you remove this from the socket, you'll get no bricks on the screen. So, yeah. Anyway. Anywho, alright. I think I will replace a few things. I'm going to pull this guy. That's definitely no good. And I'll replace this stuff here. And then I have to put this guy aside and wait for my order to come. So, alright. Well, I will be back after that. I'm going to replace this too. So, alright. We'll see ya. We'll see you in a while. I don't know, a few days, maybe a week. Alright guys, I'm back poking around on this Breakout board. I started to wonder, why does this thing always start out like it's coined up, you know? So I started looking at that section of the schematic here. And there's your coin switch, which I have wired in, and it is connected to pin 11 of F9. So when you hit the switch, it will go up, and see, this is normally connected, normally closed, so it's normally closed to ground. Okay, when you flip that switch, this will go high and this will go low. It toggles the data. It'll toggle data here on F8. Okay, and when that toggles, that will turn on, and then this will connect to ground, right? That'll go to ground. See, if this is a 1, that's a 0. Then it goes to 0, then it comes to 1, and it'll activate this guy. See, pin 13, the reset is pulled high. So this thing is just working on the set input. So once this goes to ground, this output goes high, it turns this guy on, and when this toggles, Q and Q naught will toggle, right? So I'm going to set the camera up on the tripod, and you can look at the oscilloscope, and I'll go through what I just pointed out there and how that works. Okay, so first off, I'm going to put this probe on the 74 up here at F9 on pin 11. 8, 9, 10, 11, and you'll see it's connected to ground, and when I flip the switch, player 1, it'll go high. You see that? It goes high. And the output on pin 10 will go low, like that. Now remember, pin 13 is normally high, and it'll go low when that switch is pressed, just like that. So pin 12, which will normally be low, will go high. Okay, that tells me that 74 is, or the 04 is working great. And we'll go down to that 74, and remember pin 10, so 8, 9, 10, which is normally held low. When you flip this switch, this will go high. And there it is. That activates that 74. Right? So we've got, this is the reset line, which is held high. Then you got your data line, which toggles when the switch, see, it toggles when the switch is flipped. So this serves two purposes. It activates the flip-flop, and it changes the data to the flip-flop. This is the clock signal. So the flip-flop is clocked. And this is pin 10, which when you flip the switch, it does its thing and activates the flip-flop. This is Q, which Q is sitting high right now, which makes sense because the set input is set. It's low. And that went low, and it sets, or pin 10 is low. Yeah, that doesn't make no sense. That's the set input. That should set it high. It should set, oh, it does. Duh, okay. This is the set input, and it sets this thing high. Now when I flip the switch, this is supposed to go low. And it goes about to a floating area. It never goes that low. And if we look at Q naught, the inverse, it's sitting high, and I flip the switch and it stays high. It doesn't do anything. That's a long way to get to that 74 is no good. But we got another bad part. It's one after another. So I think that is exactly why this thing is starting out like it's turned, like it's coined up already, and player 1 has been pushed. So I'm going to replace that 74, and next time I turn this thing on, it should come up in attract mode to where you have to put a coin in it to get it to start. So let's go ahead and do that. Alright guys, little update. I replaced this guy, that 74 that we talked about, and I got the same issue. It's coming up right to like it's coined and turned on and started. So I said, okay, well, I'll just keep looking. That was definitely wrong though, because I went through and tested the logic on that, and now it's working like it should. You hit the button and they toggle. So I got to looking at Coin 2, same circuit, same problem. This flip-flop right here, H9, is dead. And J9, this 3-input NAND gate, is also dead. Because I fixed this part right here, and I tested the functionality of the 79 just by hitting player 1 start. Pin 13 will toggle. Same right here with this guy. Pin 7 will toggle when I do no, pin 7 doesn't toggle on J8 pin 7. J8 pin 7. I can't do it without. I can't do it one-handed. Anyway, yeah. Let me set something up. I'll be right back. Okay, I'm back. Now we're testing this SR latch, and I have verified that I have repaired this whole chain through here. I'd already replaced H8, and I just replaced this guy. So when I switch this coin 1 switch, all of this will activate, and it'll activate this SR latch, and this pin 13 should toggle. So this is switch 1 right here. When I do this, you watch the screen up here. That's that SR latch output. I do the switch, it toggles. Okay. Now, in contrast, pin 7 over here, which is right here, which is 2-player. It's the same circuit, but it's 2-player. It's the 2-player switch. So when I toggle this, if this is all working and the SR latch is working, then this should toggle. Pin 7 will toggle. So let's go ahead and switch 2, and you can see it is not toggling at all. And what I have verified is that this H9, that 74 right there, is no good. This one I know is good right here because I've already replaced it. It's up here. It's these two right here. Same package. I replaced this guy. Then this will work right here. Then I can test this SR latch just by toggling that. This should toggle. If it doesn't, then this is bad. And I verified that this guy's bad right here, J9. Because you remember, pin 13 was toggling. Basically, this activates this. When this toggles high, this will go low. And it doesn't. It just sits there and does nothing. So it stays high the whole time. So that is getting replaced. These two guys right here, I'm going to stop and replace these two and then move forward, and then we'll do this same test on pin 7, and if this toggles, then we know that that's good, one, and that the circuit's fixed. So let me get to it. Okay, just been poking around a little bit. This thing is acting funny. You'll see it in a little bit. It will totally flake out. Now wait, now watch, it won't. Maybe if I turn it off and turn it back on. Let's try it. Nope, now it's working fine. Ugh, how annoying. When I want to show something that don't work. But anyway, this thing was going flaky on me. It would like get all askewed and it would flip and just look goofy. It looked like this. It'd look like that. And what it is, it's this chip right here. It's a 175, and one of the outputs will float. It just goes and floats. And you can jump start it though. You can take your little probe tip and short it and jump start the thing, and it'll straighten up. But I'm going to replace it because it's flaky. I'm kind of looking at these 9602 chips, and according to the schematic, I was looking at the schematic and they look like a flip-flop. They have complementary outputs. 9602. It has complementary outputs, Q and Q naught. It has a clear, or yeah, that's clear. And this is the clock input. It's basically, one of these inputs is always grounded. It's basically like an OR or whatever that is, or a NOR to go in. And basically that clocks it on pin 5. 4 will always be grounded, and you'll always get complementary outputs. So I've just been going and probing these guys, and the ones that don't have complementary outputs, I'm putting a red dot on to replace. So far there's 3. 1, 2, 3 out of the 4. This is the 4th one. I think I'll just replace it too. There's 4 of them on this board, I guess. But yeah, this thing's, boy, that's irritating that now it's working, you know. It would not work, and he'd have to jump start it. Now it's going good. All right, anyway, that's it for this little update. Okay, back at it. I replaced the 175 that was flaky, that I just last little portion of the video I showed you, tried to show you to where it would flake out, but it was working at that particular time, but trust me, it was flaky. So this guy's been replaced. I removed those 9602 chips that, when I probed them, they're supposed to have complementary outputs, and they didn't have complementary outputs, so, you know, by the definition of the logic, they're bad. So I removed these two and this guy over here. And now I fire this thing up, and it is no longer starting out like it is in, it's no longer starting out as if it's been coined up and ready to play. It's actually starting the way it should now, which is good. So yeah, I don't know if this up here is an anomaly, like it's cut off by the monitor shroud or something. I really don't know what that top is all about, if that's normal. I'm kind of thinking that that's normal. Maybe the monitor needs to shift up or something. But now you got the solid line down here. I don't think coining will do anything, but I can try. And start. Hey, start worked. So that worked. I coined it up and I started it. Now we can serve. And there's no brick hit. It's just kind of going right through there. But that's okay. We're getting somewhere. I got this 48 coming. I bought those, and that was an expensive chip. That was like a $5 chip. I bought like 3 of them. These things were like 60 cents a piece, so they were cheap. I bought like 30 of them. These guys, I bought 30 of these things at 50 cents a piece, 60 cents a piece. I'll never not have those again, you know. So yeah. So I'm going to stop and I'm going to wait for these parts, and I'll replace this guy, these two, and we'll see where we're at. Back to Breakout. Just kind of poking around, looking at schematic. I broke down and took the time to make schematic sheets. I got the whole entire schematics out in sheets, and it's a good thing I did, because I started looking over the schematic and actually comparing it to the board instead of just poking around and doing things aimlessly. And I found a huge mistake that I made. A rookie mistake. I'm sitting here and I started looking at C6 right here, this guy, and I'm like, what is going on with this chip? Because everything around this chip seemed funny. First of all, I thought E6 on the schematic was C6 until I found out that the schematic was actually pointing to E6, not C6. So I was like, okay, well, I need to find C6 on the schematic. This flip-flop, 74. You can't really read that, but it's a 74. And I couldn't find this C674 on the schematic. I'm like, what is going on? I think the schematic's wrong. Right here is C6. Does that look like a flip-flop? That is an exclusive OR gate. That is an LS86. I got the wrong chip in the board. Good grief. So I'm going to replace that guy with an 86. Lord have mercy. Okay, I replaced and put in the proper chip right here. But I was having a problem with, every now and again, the screen would absolutely just flake out and it would skew and be all curvy and stuff. And it basically boils down to funkiness down here in the horizontal count. So I'm just going to do some maintenance here. I'm replacing all of the counts, all of the horizontal counts, and I'm replacing this 37. I actually have one of these, and I'm going to replace that because that is involved in making a inverted horizontal sync signal that feeds into this 175 that I've already replaced. So yeah, goofiness. So I'm going to just bite the bullet and replace this stuff down here. There's actually a counter right here too that might be the first count off the crystal. So I'm going to replace that counter too. I'm replacing all of them down here. Got the gun out. I'm getting ready. I'll be back. Okay, so I turned this thing on. I got all these chips replaced. Okay. And I turned it on and it looked great. And then it did this again. This is what it's been doing. And I'll show you exactly where the problem is. First off, let me get the schematic and then we'll look at that and I'll show you. Okay, here is this 175. And on pin 4, it gets the carry from K1, which is, well, it's right here. It's horizontal sync. And it gets the carry from that guy. And that's the Q on pin 4. Or no, that's the data input on... Yeah. That's the data input on pin 4. And then Q is pin 2. Q bar is pin 3. Inverse. So let's look at this. This is J1, that's the 75. And the clear pin is always high, so it doesn't clear. And here is the clock, which is, it's really busy. And pin 4 has the input. There's the input looking good. That's that carry bit. Q is pin 2. Looks good. And the inverse is that. Now watch, I'll jump start it. I'm going to short these two together. Okay, now I'm not able to jump start it. But I don't know if that's just a bad chip. That pin 3 comes off and goes to E2. This guy? E2? Is that right? And it says pin 3, E2, 12 and 13 out to 11. So 12 and 13. It says that goes into pin 12. Which, this is 12. And that don't look like... Oh no, this was replaced. Oops. The speaker's popping. That's kind of cool. Anyway, where was I? Kind of getting off track. Pin 3 of J1. Where does that go? Pin 3 of J1. It says it comes over and goes to pin 12 of, is that F2? E2? Pin 12, E2, F2? I don't know. Well, it's not F2. It's got to be this guy right here. The one with no marking. But you see pin 12 has a lifted leg and a wire going way over to here. To this 86. So could it be L2? No, that's not L2. I don't know. I gotta figure this out. I'm gonna have to do some beeping out, see what's going on here. I'll be back. Okay. Not H-Sync. The only place I've been able to find it, I didn't dig too hard though, is this 107 way up here. That guy. So I am going to replace the 107. That guy right there, because I think it's corrupting not H-Sync. And while my gun's heating up, I think I'll look around for that signal a little bit more and see if it goes anywhere else. Alright. Okay, I replaced the 107 and I took the liberty while I had the soldering gun out and I replaced basically everything up in this area. This is a 192 decade counter, which I don't have, but I did buy 5 of them with my order to Jameco Electronics. I pulled this out and I put it in my tester and it tested bad, the 192. So I'll have that coming. I just went ahead and pulled a 04 and a 00. They tested bad in my tester. Goodness. But anyway, now we're back to being solid. So that was obviously that 107 was creating havoc on this signal right here. And now our signal's back to normal, not horizontal sync. So yeah, but now we're good, and hopefully solid this time. So now I am waiting on, I've done some work. I think I'm just going to remove and replace this guy when I get those chips. There's 4 of them on the board. I've already pulled 3 of them out. I might as well do 4. Might as well replace them all. I almost want to just replace every old chip on this thing, to be honest. I bought some of these RAMs too, because this output, if you remember, on pin 6 looks like that. It's half-assed dead. And what happens over time, I've noticed, is those bricks start to kind of disappear a little bit. They get smaller and smaller and smaller. That's all that RAM does, is that RAM is for the bricks. I do have some of these coming, and I am going to put a new RAM in there so that that output bit is less flaky. Yeah. All right. So we're back to solid for the time being until something fails. All right, guys. Guys, check this out. We're kind of getting somewhere. We got the ball bouncing around in attract mode now. Yeah, all right. And we can coin it. Boom. I just put a coin in it. Now I'm going to hit start. Alright, now I've started. We got our paddle. And I will serve. Oh, look at that, guys. I'm playing Breakout. Oops. 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 And it goes back into attract. Heck yeah, that's exciting. We're getting there. Woo. Just wait for these last chips to come in. That is awesome. Put it on 5 balls. And I'm going to do it again. And boom. Oh. Oh. That sucked. See what I'm talking about? There's those RAMs. See how that's flaking? That's that bad RAM signal. But we'll fix that. We are getting close. Alright, well, I guess I will, you know what, I might just replace some more I might just replace some more chips. Some more simple logic. Some of the simple logic that's left on there. There's a few, maybe a couple 32s. There is maybe a couple more 00s, some 86s. I might just go ahead and replace all of these old chips that I can while I'm waiting for, just to renew it. I've already kind of fleshed out all the bad stuff. I kind of want to just replace everything. I mean, yeah, I don't know. I guess I'll leave it the way it is. I'll wait for the chips to come in that I'm waiting on. And that's really going to make a big difference, especially that 7448 that I've got pulled out of the board that had a ton of outputs that are just floating outputs now on the board. So we're close. This thing's close to working. You know, so I'm really excited. All right, guys, I'll see you back in a while. All right, one thing really quick. Remember how I talked about these counters where the reset pin was left to float, and I didn't like that. What I did here is I've put 1K resistors across the power rail to the reset line on all 4 of these horizontal counters, just to hold that reset high, because it shouldn't reset. That'll keep any kind of a power anomaly or anything like that from dropping that below the threshold, and these will reset. So now I have it to where you see they're held high. Those lines are now held high instead of floating. I don't know why that was done like that. It makes no sense to me. That reset line should have been held high. There's no reason for them to let it float. I don't get that. Kind of a design flaw, I think, to be honest. But now that's good to go. Like most of these, this is a counter right here too, and that one's floating too. I'm going to do the same thing to that one because it's also floating. See that? I'm going to hold that one high too. And see, here's a counter right here. It's floating too. All these counters, they got floating. Just don't understand that. If they don't want them to reset, they should have held them high. So any one of these that is floating, I'm going to put that 1K resistor across it to hold it high. Just wanted to kind of point that out. There's no point of having it completely disconnected. It's a reset line. If you don't want the thing to ever reset, it should have been held high. So it just seems like a design flaw to me, to be honest. So I'm going to go through all of these counters. I'm going to look at them, and if that reset line is floating, I'm going to put a 1K resistor across the power rail, just like this, on all of them. That'll make me feel better. Okay, and what I did here is I've already had replaced these 161s, and I threw a 163 in here. It doesn't matter. It can be a 161 or a 163 as long as reset is pulled high. They are exactly the same functioning chip unless you're having a reset pulse to them. As one of them is asynchronous and one of them is synchronous, meaning that one of them works without the clock. It does not need the clock, and one works in sync with the clock. The reset pulse, I should say. When a reset comes in, it does not matter what the clock is doing. With a 163, it will reset immediately. With a 161, it resets with the clock pulse once the reset comes in. So it's a timing issue. But since these are pulled high, it doesn't matter. So I've got the 1K, and I replaced this guy because it was an old one and I wanted to solder. I wanted to do that. So I was like, you know what, I'm just going to replace it. And I did. So I got a 163 here and a 161 here. And we're back up. See that right there? How that brick is kind of flaking out? That's what I mean by this RAM. This RAM is no good. It needs to be replaced. But while I had my desoldering gun out, I went nuts and I did this one, this one, this one, and this one. I replaced these 4 chips instead of just this guy. I was like, why not? So. Oh, and then I put them in my tester, and 3 of them tested bad. Just crazy. They tested bad, but I don't think they were actually bad. I just think that they were not what this tester was expecting somehow, the way that I really don't know. Because I don't think that they were actually bad, but whatever. Cool. Now these are all pulled high. It's not going to reset now because it's pulled high. No threat of reset. No more floating reset pins. You know, all of these guys. No more floating reset pins. Breakout. And I know I just turned the camera off, but it was literally 5 seconds ago that I turned the camera off, and I just looked over here and turned it back on. See how these bricks are starting to disappear? That's what they're doing, is they're starting to disappear. And just in sections. It's that RAM. That RAM's no good. Yeah. Going away. Don't get too excited. This is the DICE emulator. It stands for Discrete Integrated Circuit Emulator. This is what Breakout is supposed to be like, look like. Now the color is color strips on the monitor, so this is actually, there's not color in Breakout. It's kind of weird that there's no bricks in the attract. I guess that's how it's supposed to be. It's hard to play this with all I have is the left and right controller. And that's it. But this is what it looks like, guys. I'm going to try one more game. See, now after you play a game, it's got the bricks in there for a tract. That's kind of strange. It's odd. Ah. Oh, one more time. I can't end it like that. Oh, I moved away from it. We're breaking out of prison, guys. Oh. We're getting out of prison. Getting out of Shawshank. Oh no, the warden got us. We're done. Kind of cool. So simplistic, yet extremely challenging. Alright, well, something to look forward to, something to shoot for, a little inspiration to play the game here, and yeah, we'll keep at it. Hello guys, it's time for part 5 of Breakout. I got a bunch of stuff here that I ordered. to complete this board. This should complete it. So let's jump right into it and start putting some chips in this board. First thing I'm going to do, those 9602 chips, there are 4 on the board and I've already removed 3. I'm going to remove and replace the 4th one too. I don't care if it even looks good. I'm just going to replace it. So let's do it. Alright guys, believe it or not, I think Breakout board is complete. It's now fully populated. I got this guy, that one, that one, and that one. Those were the remaining empty spots. So I'm kind of anxious. Let's plug this thing in and see what it does. See if we get sound. So let's do it. I'll be right back. Alright, we are hooked up, plugged in, and check this thing out, how good it looks. Remember this nonsense that was up here, like double? Now we've actually got counts. It says 2 and 4, whatever that means. And you got an 8 right here. I don't know what all that means. But it's looking good. Let's coin this thing up. Okay. Okay, coins are in it. And start. Alright, now we're going. And here's the serve button. Let me restart it again. Serve. I'm not getting any sound. I don't know if the pot's any good or I don't know. I'm going to have to do a little investigation. I'll be back. Let me investigate some things a little bit. Okay, so naturally, I've jumped a 380 LM380 over the sound amp. And I will try to coin up, start, serve, and try to do this. So the sound amp is dead. So I'll have to replace that guy. And I'm going to look into the circuitry because there's supposed to, the ball is supposed to start out slower. So I think there's something wrong with the circuitry that for the starting of the game or whatever. I'm going to do some research and see if I can figure that out. Because I'm pretty sure it's supposed to start a lot slower than it is. So I'll be back. We'll look into that. Okay, I've just been kind of poking around a little bit, and since I put some new chips in it, and especially this guy right here, which remember had a bunch of signals on it, had about 5 outputs or something like that, 6 outputs going around and feeding parts to the board. So I decided to just go poking around a little bit more on old chips, and I came across this counter. I don't even know what this does in the game, but there's no clock. It's just low, so it's not counting. The input bits are all low. They're almost kind of floating. The enables are enabled. There's no load, but there's no no clear. It's not cleared, but it's not counting either. There's no clock, but the carry bit is stuck high. That carry bit should not be high like that. So this thing is no good. I don't know what it does, but all the counts are at 1, and all the inputs are at zeros. There's no count. Carry is stuck high, so that thing's no good. That's a 161 counter. I'm gonna replace that. I'm gonna pull that out and get rid of that. And that'll do. I kind of want to look this up on the schematic too and find out what it does. This counter right here. That is what, B4. So let's do that. I'm going to look up B4. I'm going to replace it, look it up, and see exactly what it's doing. Look at that carry bit. This carry bit's stuck high. It should be low. So I want to see what clocks it, what event clocks this thing, and what happens. Just curious. But regardless, it's no good. So here's another one. Alright, I got the desoldering gun out to take the sound amp out. And I got the sound amp out. And I didn't stop there. I kind of went a little nuts. I removed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I removed 11 more chips. This row. Couple here, and here, and here. Yeah. I just kind of got carried away. I'm like, you know what? Why not? So I'm going to go through and throw these into the IC tester and see what it says. Got any of these things that are bad or what? Alright, so we're back fired up again, and one thing I noticed right off the bat that's different is the 1 and the 1. That's for one player and that's for first ball. Now I don't know about this 010 and 070, maybe that's the score. That should zero out once the game starts. So I'm gonna, well, let's go ahead and coin this thing up, see what happens. Do a start, and it did go to zeros, and a serve, and where is the, I gotta get the paddle. Try to serve again. And it's nice and slow now. How it should be. I can't go up all the way. That ain't right. Ah. Hey! So it did count right. I was not keeping track of the score, but 0 credits, 4th ball, I think. I don't know. I didn't really pay attention. I was more concerned about the fact that the paddle wouldn't go all the way to the top. So it's way better than it was, though. We got sound. It's cool. So I got to investigate the paddle. Why the paddle stops at the end there. That ain't right. So that's the next thing to look at. But good improvement. All right. We'll be back. Alright, well, I went through the good schematic on my computer and wrote down every gate, every chip that is used in the paddle circuitry right here. And you see J204, which is this guy right here. I was really not wanting to mess with this because of all this, you know, stuff done to it, and I really didn't want to mess with that junk. But I'm going to have to just bite the bullet and replace these parts right here. I'm going to replace these 4 guys. Yeah. Just get it done. Alright, I'll be back. Okay, well, I figured out the paddle. If you look up here on this schematic, you'll see it's a 5K pot, and you got 5 volts. I had ground running to the pot too. And then I got to looking at this closer, and I was like, well, they don't have, so this is just a loop. There's no ground reference. And this 4016, I read somewhere that 4066 was an upgrade. So I put a 4066 back in the board. That's originally what was in it when I got it. So I put a 4066 in, and I snipped the ground. And now you'll see it is all the way up to the edge smooth, all the way down to the other edge smooth. So that was it. It was just needed a 4066, and I needed to just cut the ground. See, I cut my ground here. And that was it. So now that's working right. The only thing that's really kind of funky with this thing is I think it's supposed to, when you turn it on, it's supposed to come up with no bricks, and it's supposed to be in attract mode. I'll show you what it does when you turn it on. Turn it off. Now I'll turn it on. It just comes right up to this screen. And I think the bricks are supposed to be gone, and the ball is supposed to be just bouncing around, I think is what is supposed to happen. I'm not 100% sure of that, though. I think I'll need to look this up on YouTube, this game itself. Not an emulation or nothing. I need to look at the real game. Or if somebody knows, could you chime in? But the ball went from being slow to it's way too fast now again. I don't know what is going on there. I'll coin up and I'll start and watch the serve. Fastball. I'll try it again. Fastball coming up. Ah. Come on. Ah, I moved away from it. I keep moving away from it. I mean, it's really close. It's almost good. Just a couple things to figure out, and it will be done soon. Okay guys, I have been pulling my hair out over the fastball, and I think I have found the issue. This chip right here has an input on it that just looks super funky. And I think this chip, this old chip right here, is screwing it up and making it bad, I believe is what's going on. I kind of want to look at... Let me hook this thing up. I'll be right back. Okay, I got you focused in on that. I'm going to show you this signal I'm talking about. It's on that 08. That's it right there. It is pin 4 of A4. Pin 4 of A4 is goofy. I'm just kind of messing around with that signal right now. I kind of want to play around with this a little bit. Yeah, come on. See, now the ball is going slow because I've been messing around with it. I want to show you. I've just been shorting around on that thing and the ball was going slow. It's starting to speed up now. Long story short, I'm going to replace this guy, and while I'm at it, I'm going to replace this old 00 and go from there. Alright, I'm going to play a game and you'll see that the score does not count correctly. Start a game and go, and it's still super fastball, and you see I hit a brick but it didn't count a score for me. So it's gone 0, 2, 0, 4, 0, 8. Nothing 2, nothing 6. So it looks like it's going 2, 4, 6, 8, 2, 4, 6, 8. You know, it's got a stuck bit basically. So those 160 counters are no good. The score, I have noticed that the scoring is kept in these counters right here. This is player 1 score, this is player 2 score, and I've already replaced one of the 160s. I'm going to go ahead and replace the rest of the 160s. At least get the scoring right, and then got to figure out old fastball. Maybe that will affect the fastball. Who knows? I hope so. Let's go ahead and replace these guys. I'm just going to replace them all. I'm not even going to test which one's bad. We're just going to replace every one of them. Alright guys, I replaced those 160s up here, and I had the exact same issue. And if you look at the schematic, which let me find the right one, and this is a big deal. These are those 160s, and they output all of these score bits, A1, B1, all the way down, you know, E, F, G, H1. All of those score bits come down and are multiplexed through these damn things, these 9312s, which, remember, I was like, boy, I hope those aren't bad. All of those score bits go into those guys, and then that is whatever this 48 chip is, remember I bought, and outputs all of these, which does all of this business. Horizontal, you got vertical, and it feeds down through this 55, feeds into this circuitry, which comes off of all of this, and that makes I believe all of this circuitry and stuff has stuff to do with the, I know it does, with the ball speed and stuff like that, because it goes based on how many bricks you hit and your score and stuff like that. So I have removed all of these guys out of the board. There's 6 of them. Those 9312s. And I found a source for those 9312s. It is a basically a closeout house, electronics superstore type deal. And I was able to source those chips. So that is what I'm doing now, is I'm just waiting for those chips to come. And we'll pick back up. I just ordered the chips, so it's going to take a little bit before we get back to this guy. And in the meantime, I've got a couple of things I can get to. I got a battle zone that I can get to. Something else just came in. I'm not even sure what it is, and I got a couple more things in the wait. So we're going to put this one on hold again, guys. So I was hoping that I could just finish this thing with this part of the video, but I am going to have to stop and upload this as part 5, unfortunately. And part 6 will be when those chips get here. So we'll see you then. Okay guys, this Breakout board, I'm getting back to it. You remember these 9312s that I removed out of the board? I had found a source that had those, and I purchased them, but then I got an email and they canceled my order. So I was at kind of a loss. I think they canceled my order because I wasn't a big company. Yeah, I didn't have a company name, or, you know, an official company name or whatnot, so they canceled my order. So I was kind of like, well, what am I going to do? Remember, these 9312s are basically the same operation. They're the same functionality as a 151, just a way different pinout. So I said, you know, I guess my only option is to make an adapter. So that's what I did. I designed a little adapter to go from 9312 to 74151, and here's my little adapters. 6 of them. I have gone through and I smoothed the edges. I just got these in the mail from Osh Park. Just a simple little adapter. It only cost me like $10 to have 10 of these made and shipped to me. It's just a little simple adapter where this board will go right here, and I'll have 6 of them on the board. So I'm going to go ahead and start soldering the leads into this and everything, and let's get to it. Alright guys, I'm using my breadboard to assemble these because it's just easier that way. I'm going to try to work within this frame right here so that you can see what I'm doing. Let me go grab my coffee. Stop running around, please. What is your problem? Okay, yeah. Let's get my solder. Okay. Alright, try to work within this frame. Happy Sunday, everybody. It's the 27th. I hope everybody had a very Merry Christmas. And we're just going to solder these leads in here. Pretty simple. You know what? I need my stronger glasses. I'm going to be doing this like this. Yeah, much better. There's that. Alright, and there's one adapter. Just like that. The 151 gets soldered in right there. So next we'll go, let's try right here at the 5. Is that in frame? Let me check. Yep, that's pretty good. So we'll start right at the 5 mark, go down with that, and then right here, that's too far I think, or is it? Oh, that's right. Okay. Next. Yeah. And we're still in frame, right? Absolutely. Good. Nice little adapter. There's always more than one way to do something, you know. And you know what? I do want to give credit and give a shout out to Brian B. I am sorry if you're watching. I don't know how to pronounce your name. But he's over at arcadecabinets.com on YouTube. Arcade Cabinets on YouTube. I followed his tutorial exactly to the T of how to do this. Of how to make this adapter. So I do want to give credit and a shout out to Brian over there. It's really, really simple, you know. But it's not simple if you don't know, if you've never done it. Arcade Cabinets YouTube channel. Arcade Cabinets. It's he's got a tutorial. He's got a lot of cool stuff on there. You guys should check that out if you haven't. A lot of cool stuff. Okay. Pop that out. There's 3 of them. I was just looking on this breadboard, see what in the heck was going on. What was I doing here? I need to put all these parts back into my stock. There's a 2N2222A. Yeah, this was my first foray into doing any kind of PCB designing or anything like that. It was a necessity, see. I've never felt the need to do anything like that. But this time it was a necessity, so I did it. There we go. That down on there good. Just let it wick around there really good. Get a good connection. All right. And this will be the last one. Last one. There we go. Get on there. Okay, that's going to do it for that, and we got all of our, they're all on there anyway. Now Yeah, it's going to be interesting to solder through there, but I can do it. I got a fine point on there. No problem. All right. Be right back. Okay, I've got my adapter chips in the board. $151 adapters. And I've got the game up, and we'll see if this thing scores correctly. How this score works: there's 8 rows of bricks. The first 2 rows are worth 1 point. The second 2 rows are worth 3 points. The bricks in the 5th and 6th row are worth 5 points, and the last 2 rows are worth 7 points. That's how Breakout is scored. So I'm going to put the camera up on here and play and see if it's scoring correctly at least. I'll be right back. Let me hook up to the camera, or put the camera on the stand, and we'll play a game and see if this thing is at least scoring correctly now. Okay. Ow! Damn, I stepped on something. Okay. Oh, coin. Start. Serve. And it's still super fastball. Come on. Okay, 1, 2, 3, 4. Oh. Those are all 1 point. Well, no, that's correct. 7's correct so far. Let's play again, see if I can do any better. This is about impossible to do. Super fastball. It's ridiculous. Damn this. Oh. 1, 2. Yeah, see? It's counting right now. Those are worth 3 points. So I've got 1, 2, 3, 4. And then I've got 4 times 3, 12. No. I've got 1, 2, 3, 4 points. And then 2 at 3 is 6 and 10. So it's 10. The score is right. Come on. One more try. So our scoring. Oh. 1, 2, 3, 4, 5. That's correct. One more ball. Damn this thing. One more try. One, 2, and that was a 3-pointer. And another 3-pointer. And another 3-pointer. And another 3-pointer. 1 point. 1 point. 1 point. Yeah. That was a 3-point ball. And so it is counting correctly. We can count our score right here. Okay, first 2 rows are 1 point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we are counting correctly now. One more thing to figure out, and it's the ball motion control. I got to look at the theory of operation and get with the whatchamacallit, the theory of operation, and about the speed of the ball. It's a problem. All right, cool. This fixed that dang scoring issue. That's good to go now. So let's move on. Finish this ball speed thing, and this board will be done. And guys, by the way, I wanted to point out, I forgot to point out, I have temporarily made a little adapter to hook to a switcher, and I removed all of this so that I could run this on a switching power supply, because I'm going to rebuild. I'm going to rebuild the AR, I'm going to rebuild the onboard power rectifier with a new cap, new diodes, new regulator here and everything. And I temporarily put a 12-volt line in right here and had to run this so that I could get sound. This is not here in the arcade cabinet itself. I just put that in there so that I could power the amp. You know, in order to do a switcher, you have to cut a trace on the back, which I'll just jump the trace, you know, I'll just jump the trace back when I rebuild it this way. And yeah, so because the way this thing works for the amp is you get, it's like 16.5 volts AC comes in and gets rectified, and then that 16 volts runs over and powers the amp, and then the 16 volts also gets regulated to 5 volts here. So the board gets 5 volts while this gets 16 unregulated. Well, when you run regulated 5 in, then it's regulated 5 everywhere. Over here comes regulated 5. 5 volts won't power this amp. You won't get sound. It needs to be at least 12 volts. So you have to cut the trace on the backside to isolate the 5 volts from a switcher off of that. And then you run 12 volts. You just jump 12 volts over to the amp. So it sounds more complicated than it is. It's just basically cutting the 5 volt trace off of this so that you can run 12 over here. This was just a pad to nowhere. You know, that right there was just a pad to nowhere. It didn't do anything, so I just hooked my 12 volt line up to it and jumped this wire right over to the amp. That goes right to the amplifier. So when I rebuild the power, I'll remove that. I'll put the trace back so that that unregulated voltage can get over here. Put a new, I'm going to lift this up about 1/8 of an inch off of the board so that some air can get underneath this. Because he wants to run this, and I don't blame him. Original, you know, run it original. So I just wanted to do that because I'm going to rebuild it anyway. So yeah. But if you want to, in your game, that's how you do it. If you want to run a switching power supply, the collector's case, for God's sake, the case of the TO3 guy on this regulator is ground. This is input and output. All you have to do is jump the input and output, and then jump your diodes. Just jump where the diodes were, jump the input to the output, remove the big power resistor, and you've got regulated 5 volts comes in. Yeah, so that's pretty simple, but you got to pay attention to what your sound amp needs. Sound amp always needs 12 volts at least, so you'll have to isolate the 5 off of the sound amp and then jump 12 volts over to it. So I hope you understand that. Anyway, cool. I'm going to actually rebuild the power on this thing now, and we got one thing to figure out, and it's the speed of the ball. And that should not be that hard to find that. It really shouldn't. This thing has a really good detailed theory of operation, so it should be right in there. And we'll check it out. Okay, I'm just getting ready to rebuild this power section over here. I'll try to keep this in frame. I've removed the little things I had in there. Man, this baby's plugged up a little bit. I'm going to have to give it a little bit. Give it a little bit of solder. Let me see something. There we go. That's clean. I got these couple of nuts here that I'm going to use to lift this guy up a little bit. We can go ahead and I use these silicon whatever they are. I like these insulators. You don't have to use paste, and I just like them a lot better. So we're going to go ahead and assemble this. And this is a little tricky. It's best to just do it upside down like that. And it's going to go on here like so. And we will try to thread this screw up through the bottom. And I really mean try. Here it comes. Okay. And this is going to be tough because I can't hardly do this like this. I'm just going to have to try to hold this and turn this screw. Hopefully turn it the right way too. I can't tell which way to turn it. There we go. Okay. Now let's get this other one up in here. Good. And do the same thing. Just hold this and loosely thread this thing. Get it started good and you're good to go. And that's about got it. So now I'm going to go ahead and come out of frame a little bit because I gotta screw this in. Okay. And I'm going to, I need a different screwdriver, I believe. No I don't. I just need to hold on to this and thread this in from the bottom, from the back side. And just screw it tight. Good and tight. Alright, before we do anything, before we do a darn thing, I am going to beep this baby out. Make sure, you have to be sure that this thing is not grounded. So you want to grab the collector. This is the collector. Just make sure, okay, you got continuity. You have to just do this. Make sure you're not grounding ground to the input or the output. Right? And you know it's not a bad connection because you got continuity between, you know, across the collector. But you cannot have continuity to the in or the out. So that's ready to be soldered in. So we will, I need a different iron tip. I need a more heavy duty iron tip. For this kind of stuff I like using this guy. And it is still hotter than shit. Okay, fire that up. It'll take a second to get hot. And we're going to solder in this guy. Just like that. Can't really see. Trim these. And just for good measure, one more test, continuity test. Collector to collector, good. No short. Good deal. And okay, now I need power diodes. Let me grab a couple power diodes. Okay, I got the two diodes for two 3-amp diodes, and they need to be folded right at bent, I should say, just like this. Okay, and it's cathode towards the regulator, of course, and down in there. Big 3-amp diodes. Okay, just like that, we solder those guys into the board. Damn, so much. Yeah, I think that's about got it. It's a lot of heat. Now. Okay, the big old diodes, that's that. Cap. This originally was an 8,000 microfarad cap. I'm putting a 12,000 in there because I have it. And it's a filtering power, you can go up. If it's like a passive where a signal is passing through, all this is a smoothing capacitor for the 5 volts. So you can go up. I'm putting a 12,000 in it. It's just more filtering capacitance, so it's not a big deal. Nice new capacitor, 12,000 microfarad. Okay. Positives over there, so we'll bend there and we'll bend here. Pretty good. Solder this baby on the top. And now we'll turn it over and we'll finish it up. Just touch it up. I mean, don't really need to do much of anything. Just like that. And just like that. And the aforementioned trace that I cut to do the power for the sound amp, I have replaced and repaired that trace right there. Which there's a little bit here, I can do that. So that's a repair on that, and I removed this guy, that wire that I had going there. So now all I need to do is put in the big old power resistor, and I'd like to do a brand new one. 4 ohm. And I got these big old 25 watt guys, and I'm going to put one of those in there. But I'm going to leave these leads like this, and because this is too big, you know, it's a little bit big. So what you need to do, what I'm going to do, is fold this about right here, bend it, and then I'm going to bend this one about right here, like that. See how I got that formed? And that'll drop right in here. Perfect. And what I want to do is leave it off the board just a little bit and go ahead and solder it. I need my glasses. I need the Coke bottle glasses for this. Get under there and solder that. Top side. Just like that. I got it tacked top side. And we'll, yeah, that's perfect. Let's nail this. Yep. And yep. And ow. Yeah, that's perfect. I'll show you this in a second. Okay. Now I'll give you, that's the power. Power's done. So I'll give you a good close-up view of it. Let me grab my smaller glasses. Let's remove the camera. And okay, here's the power section. You see how that's off the board a little bit there. And here's that power resistor. See how it's done. It's off the board a little bit. 4 ohm. They're normally a 10 watt resistor. This is a 25 watt, so it's handle a lot more. So that's good right there. That's that. There's your cap, your diodes with the cathodes pointing the right way. And there's my repaired sound amp trace. Alright, so we're ready to fire this. I want to fire this thing up and check the power, make sure the power's good. Look at those. Those little things are nifty, aren't they? I'm digging those. And I'm digging that the thing is counting right. So let's fire this thing up and check it out with the new power. Alright guys, going over something really super strange. And I don't know if it's this guy right here. Anyway, as you can see, I've got this thing out of the board. With this 4 ohm power resistor in the board, I know the concept that this adds resistance and it actually gives this more current. Okay, I get that. I don't think this thing needs the current, the extra current, the resistor, the power resistor. Because I have it, when I had this in the board, and it was doing this before, and that's one of the reasons why I took the power out. One of the reasons why I took the this stuff out and had it hooked up to a switcher was I checked the voltage, and the voltage was at like 5.5 volts on the rail. And I tried another one of these. This is the second one that I've tried, and it was doing the same thing. 5.5 volts on the power rails. So knowing that this thing boosts the amperage, it's a helper, it's a helping resistor. It basically helps this thing get the amperage up and everything. It's 4 ohms. What I've done is removed it, and I got 5 volts on the nose, like 5.03 volts on the rail. And instead of this thing waving all over the place, I got a perfect picture. So long story short, I don't believe that I need this resistor, this power resistor in here. It's really strange. I don't know. But now I've got perfect power. I got a perfect 5 volts with the AC. If I put the power resistor in there, I get like 5.5 volts. And I've tried different regulators, and it didn't seem to matter. But I'm going to go with this. I'm going to replace these caps. I was kind of pulling my hair out over this power thing. I clipped the caps. I clipped them. I was like, maybe one of these is doing something funny. I don't know. But I'm going to replace those guys anyway. And then that's why you don't hear the speaker, is because I clipped this. So I'm going to go ahead. I mean, that's an absolutely perfect solid picture. It's perfect. And I got a perfect 5 volts. So I'm going to leave it. I'm going to redo these caps, and then I'll be back. Okay, I've got it started acting flaky, and ouch, damn, that thing gets hotter than crap. You know, this thing is flaky as all get out. Look at that. With this AC power, this thing is just goofy. I put this back in there because without it, the power was better. I'm at 5 point this. But it's just flaky as can be now. I can't get it to stabilize. I don't know what's going on. This thing doesn't have hardly anything for decoupling capacitors. I think the best course of action for this is to run this on a switcher. That's when it behaves the best. So I'm going to remove all of this and I'm going to put it back to on a switcher, and I'm just going to tell the owner of this thing that you need to run it on a switcher. It's just not going to work like this. This thing's just flaky. I don't know. I don't know why. I don't know why, guys. But it is. But it's not flaky if I run it on a switcher. But it is like, look at that. Look at the paddle going bananas. Yeah, I don't know. Yeah, there's like no AC ripple on this line. I've got it on AC right now on that capacitor. And it's saying like millivolts, like 60 millivolts. That's fine. That's not a problem. I don't know why this thing doesn't want to run like this. I don't know. But it doesn't. Maybe it's just this. Maybe it doesn't like that transformer. I don't know. But I'm going to advise, and I'm going to take this stuff off. And I'm going to do this as a switching power supply setup. Because I don't like that. If I have this on my switcher, it's perfect. So I'm going to revert it back to switching power supply. Okay, we are set back up switcher wise, and I'm at 5.01 volts. This is just for looks. This thing is not even connected. I clipped the legs basically even with the bottom of the case and just put it here for looks. It's not doing anything. You can see the diodes have been replaced by jumpers. And then this is jumped underneath here. You won't be able to see that, but the input is jumped to the output. And I had to redo my speaker connection 12 volts, and had to remove my trace fix on the back side of that, because you need to just run 12 volts to the amp. So we're back to switcher wise, and it looks great. It's solid. It's not flaky at all. So this thing just loves switcher power. So this thing's going to be switcher power. And we're at 5 volts. So I'm going to go ahead and unhook this guy, because we're good to go on power. And what I want to do is test the paddle movement. So we'll coin this thing up. Remember, it was all jumpy and flaky. Start. And look at the paddle. Smooth. Nice clean power. It just makes all the difference. I know it's still going to be super fastball. And that's just, yeah, see, boom. Oh boy. Yep, it's super fastball. I got to figure that out, but we're good right here. That's a known good state. I'm going to leave it like this. We're counting good. Everything. This should not be a big problem now, figuring out why the ball speed is not correct. So that's the next thing to look at. And I'm probably going to end this video now, because it's give you guys some content to look at, because I don't know when I'm going to be exactly getting back into this. It might be a little bit before I look at this thing any further, so who knows. But I'll be looking at it, and hopefully we'll have a finished video soon with some gameplay. The only thing that I have to do now is fix that ball speed. That's it. This thing, as far as I'm concerned, is switching power supply only now. It just does not want to run with AC power. And I don't know why. You know, so it is what it is. All right. Okay, guys. I went over the theory of operation, and this counter at B5 is a 193, and it is the volleys counter. This thing should start out at 0, and it should start counting at 0, and this SU signal, when you hit the back wall or something like that, it lets you know that it lets the system know that all of the bricks are gone or something like that. I don't remember exactly what it said, but that'll load all ones and the ball will be at top speed. I think this thing is loading ones in running at full speed right from the get-go. I think this chip is bad, this 193. And I went through my stock of 193s, and I only had a handful of 193s. I had about 8. And all of the National Semiconductor ones that I tested in my tester were bad. And that's what I put in the board. So I did have 5 of them that tested good, that were a different brand, so I'm going to put, well, actually I had one National Semiconductor that was good. One of them was good. So I'm going to put one that tested good in the board and see what happens. I think that's going to fix the problem. Alright guys, weirdness with Breakout. This is this is the most frustrating repair. Well, I'm not going to say it's the most, but it's one of the most frustrating repairs that I've ever done. I have my logic probe hooked up because I'm going through and I can't look at the screen and play this game with super fastball. So what I've done is I turned the sound down, and I've been beeping. You know, I'm using my audible logic probe to see if this thing pulses when it's supposed to. Right now I'm hooked up to the clock signal on brick hit right here. This circuitry right here is the ball speed. All of this. Now I'm kind of starting at the beginning over here, and I've checked this guy. This signal's there. That's fine. When the ball hits the paddle, that bleeps. And this one right here is like the sidewall. Whenever the ball hits the sidewall, it bleeps. And this is the back wall, the top wall. I can't get to that because, yeah, top sound, it's when the ball hits the very top of the screen, and I can't get to that. So, but I've got my probe on brick hit. It's the clock signal to this guy, okay? And I'm just wanting to see if every time I hit a brick, if this toggles, right? Because it should. That's what that signal is. It should toggle when you hit a brick. So I've got my logic probe hooked up to pin 3 of that guy, right? And I've got this running to there. And it's just, I don't know what it's doing, if it's pulling this low. But anyway, I can serve the ball and watch. Notice there's no, whenever I hit a brick, there's no beep. But this is working perfectly. Now it speeds up after 4 volleys. This thing speeds up after 4 volleys, and then after 12 it speeds up again. So I'll go ahead and serve. Shit. I can't even do it when it's slow. Alright, start over. See, there it toggled. And I'm sorry if things are right in your way. Yeah. Anyway, if I undo this, I'll go ahead and unhook that. Watch, it'll be super fastball. Once I hit, there it goes. Boom. Super fastball. Just absolutely strange. So it's something to do with that signal. Brick hit. So I'm going to find that. It might be this chip. I don't know. But I'm going to... Goodness gracious. I don't know if this chip is holding that signal, but I'm going to find out where this brick hit signal comes from and check that out. This is supposed to toggle when it hits a brick, I would think, and it's not. You know, and I don't know. It's very, very strange. But one thing that I have noticed, and this is awesome, this absolutely is 100% working correctly, because this thing has those 9602 multi-vibrator chips. You know, they create the did-it sound, did-it, you know. When you hit the bleeps, when you hit a one score brick, it just goes beep. But when you hit a 3 score brick, it goes beep, 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 really quick. It beeps 3 times really fast. And I imagine when you get to hitting a 5 point brick, it'll be beep, 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 you know. So that is absolutely working. That is incredibly awesome. So, and I'm tracking down, I am almost there to finding this. I finally found the problem. It's that signal, brick hit. I just have to investigate and get that squared away, which we will do. So I'm going to go back to the schematic and look at it for a little bit. Find brick hit. It's either going to be this flip-flop or it's the flip-flop for brick hit. Something's not right. This thing is supposed to toggle when it hits a brick. I mean, that's the name of the signal, brick hit. So awesome. We're getting there, guys. Part 7 will be the end of this board. Thank goodness. Alrighty, be back. Okay, so I have gone through and hooked this lead up to every one of these inputs and outputs. Pins 1 through 7. 1 through 6. Pins 1 through 6. And the only one that makes this thing work correctly is when I hook this to pin 3, which is the clock input here. The brick hit signal. So something connected to brick hit is causing the problem, I believe. So I just got to go through and look at this brick hit signal everywhere and find out what is making this thing funky. So that is what I will do. It doesn't happen with not brick hit. It's only brick hit. So I'll have to check that out. We're getting there. Okay, so I followed the brick hit signal. I followed it around to where it was created, and it's created right here on this guy. So I just grabbed a 74 out of my stock, and I placed it over that guy, which is right here. So I just kind of placed that right over that guy. And I will start this thing up and serve. Now how this works, after 4 volleys it'll speed up, and then after 12 volleys it will speed up again. And if the ball hits the very top of the screen, it goes to max speed. That's how it works. So 1, 2, 3. Next one will speed up. And I missed it, of course. I gotta change my hands, and I gotta take my glasses off. Alright, let's try this again. 1, 2, 3. Next one will speed up. There, speed up. Now 4, 5. I'm gonna try it again. You gotta count. On the 4th count it'll speed up, and then on the 12th count it'll speed up again, if I make it that far. And here we go. 1. Damn it! I suck. 1, 2, 3, 4. I'm just terrible, but it's working now with that chip jumped. So I'm going to replace this guy, and hopefully that fixes it. This might just be creating enough capacitance or whatever to make it work right. It still might not be this part, but I hope it is. I'm kind of chasing this problem around right now. Hopefully this is where it starts. So let's start where it starts and replace this guy. Alright guys, what turned out to be the problem was not this guy. This is the first one that I removed right here. And I socketed it and put a new 74 in there. The bad part was the one that I was probing the whole time, right here. This chip is actually the one that I took out of the board right here. I just took it out of the board and ended up replacing the one that was in the board right here with the one that was right here, because it's fine. The bad chip was the one that was right here. And it's funny, it said in my tester, my IC tester, it said it was good. And I'm looking for that chip. I think I already threw it away. But it was in the board right here. Yeah, so it's working proper now. We'll go ahead and coin the thing up. Start. Serve. Fourth volley coming up, it'll speed up. Yep. Now it'll stay this speed for, oh, just sped right up, didn't it? Two, 3. Dang. Oh, let's. I'm gonna set the monitor up on its side so we can get it. I can actually play this thing good. Set the camera up. That way I can actually play it good. So let's go ahead and do that. Okay, and here we go. start over. Try to get a little more. Uh-oh. Uh-oh. Yeah, I wanted to start over anyway. And here we go. Whoa, okay. Nah, it ain't working right. Still ain't something right. Oh, goodness. It's still not working right. Yeah, it counted up 11. What in the world's going on? What is going on here? Well, 4.95 volts. We're still right at 5 volts, which is good. Oh, what's going on now? Okay, guys, I don't know. I'm going to have to come back. I'm going to have to... You know what, let me do something. I'm going to try something. Because I've changed this chip and it got worse than it was. I'm going to try replacing this thing again. Let's see what happens. Nope. One second. Heck of a lot of trial and error going on here. I'm going to put this chip back in here and see if it acts goofy again. Yep. Yeah. This is no good. This chip is no good. Well, it would help if it's in the circuit. Let's do this. And I've just been swapping chips around. Fast to start or slow to start and then fast. Something ain't right. And it just counted 10. Back to the drawing board. Goodness gracious. We'll be back. Alright guys, I started clipping legs that were attached to the brick hit signal, and then I started clipping legs that were involved in the ball motion control counters. And I clipped one on an LS00 that provided the load signal for the parallel load signal for the ball motion control counters. And when I soldered the leg back together after I clipped it and verified that it wasn't my problem, it started working. I don't know. I don't have any idea why that is. But I'm going to go ahead and kill the lights. Yeah, it's the weirdest thing. I don't understand. This has been a weird situation. A weird thing altogether. So go ahead and start it up and coin it up. Credit, start, serve. Oops. And get ready. Darn it. Remember, 4 volleys, it'll speed up. 2. 3. Next one, it'll speed up. Now there's 5, 6, 7, 8, 9. It'll speed up on 12 if I get there. 10, 11. Next one, it'll speed up again. There we go. Perfect. We're counting perfect. See, it's counting perfect. It's working perfect now. And if that ball hits a 5-point brick, it'll speed up to the fast speed. Ah. Damn it. See, that's a 5-point ball right there. And it speeds right up. Once that ball hits a 5-point brick, then it speeds up to the fastest speed. Mine, it's not lightning fast speed. Like if it hits the top of the, if the ball hits the very top after you break out, quote unquote, then it gets to lightning fast speed. I'm gonna go again. Try to, I want to do a breakout. I want to get the ball through the bricks. I'm just not that good. See, that's not right. That wasn't right. Now we're back to funky. It was working, and now it's not. Now it's working. gets to that 5-ball speed and I can't handle it. This is my last ball. Oh, that's not a bad, it wasn't a bad game though. Nice. I got it set on no bonus. I should have a bonus at 100 points. 100 points is pretty good. I almost got through that one spot. But I need to replace some of the decoupling capacitors that are broke on here. Oh, that might be the whole problem. I don't know. Yeah, there's 1, 2. There's a handful of them that are broken. I have 3. Oops, 4. Alright, I'm going to do some cap replacement. Be right back. Okay guys, I got to playing the game and it was playing perfect, playing great. And I set the score, free game. You know, there's a free game selector, and if you can set it to 0, you know, no free game. You can set it to 100 points. You can set it to 200, like 400. You know, you can set it at different levels. I set it for 100 points, the easiest that I could make it. So I just make sure it worked. And of course, it didn't work. So I removed the remaining 4 chips. These guys right here. I just pulled them out of the board, and they're all right here. There's this 20 that goes right here. There is the 86s. Heck, I don't know where the 86s are. I guess they're not involved in this. Well, I removed those. I didn't have to, I guess. Yeah, I don't see the 86s. Anyway, we got this 20 that goes here. There's 2 86s here and here. And there's a 08 here at, what is that? N7 maybe? 08, N7. That's this guy, free game tone. Right? N708. Free game tone. Turns out that I put that in my chip tester. That 08's fine. The 2 86s were good. But this 20 here, which takes the most significant bits of your score. Oh, there's those 86s. Yeah, there's the 86s. So they were involved. Those tested good. But the 20, I've got the 20 in the tester and it comes up not found. LS 20. Fault. Okay, so we had the 20 was bad in this circuit right here. That's why I wasn't getting free tone. I'm going to put new chips in the board there, and then I'll play it again, and hopefully at 100 points I get the free tone. So let's do that. I'll replace these guys and we'll set up and play. Alright guys, I was just on fire and I scored 414 points. Cleared all of that. Okay, let me go over what was going on here. I replaced these guys, and you remember the 20 was bad. And I played it and I got the same thing. No free guy, or no free game, or whatever. So I started, I just beeped out the switch with them all off, and one of the things was still on. So this guy was no good. The switch has a stuck on line. One of the lines is stuck on, and it was one of the low ones, so the free guy, the free game thing was like way with a really high score. So what I did is I just jumped it at 100 points. I took the switch out. I don't have a four position dip switch, so I just jumped it to where it is at 100 points. You'll hear the buzzer and get a free game. And I verified that, and it does work, because I got the free game buzzer when I played this game. So what I will do is demonstrate that. This thing has now been completely replaced. Every component, every part on this has been replaced now. Those were the last 4 guys of the original board. And the switch was no good to boot. So, quite unbelievable. But yes, we will play a game and let you check it out. Heck yeah. I gotta cut this off. I got this little capacitor stuck to this. I was just testing something. I gotta take that off. But yeah, this thing's working 100% beautifully now. So we'll go ahead and play a game, and hopefully I can get to 100 points. I won't stop until I get to the 100 points so that you can hear the buzzer. So yeah, alright guys. And by the way, I forgot to mention, guys, I put extra decoupling caps in along the rails. 1 per rail over here. Decoupling cap. I got 1 right. No, I don't have 1 right there. 1 right here, 1 right over here. Yep, and then over there, up there. And then I put in a few over here. 1 right there. 1 right here. And 1 right there. So I put in a little bit more decoupling. I replaced the guys that were broke. This one, that one. And this cap was broke. That's a 0.01. These other ones are 0.1. So hopefully that'll eliminate some of the noise, make it a little less noisy, run a little smoother. That's all. Just trying to make the signals a little smoother, that's all. Alright, so let's go ahead and set up the camera and play some Breakout. Play some finished Breakout. Okay, right now I'm doing lighting testing. LED lights, the coin or start lights and whatnot. I'm simulating that stuff. And I have wrote right here, I got the pin out, and the serve LEDs, this is for cocktail table, which is, these are active low. When this signal goes low, the LED will light. And this is for an upright cabinet, which is what I'm set at right now. And it's active low, so when this signal goes low, the LED will light. And right here we have start lamp. These, the signal has to go high to light, because the other side of the lamp is connected to ground, so these output a high to light the start lamps. So first thing I'm going to do is look at the LEDs. Start LED 1 for upright is P, which is this guy right here. So this goes low when you put in this is a serve LED. So we're going to coin up. Now when I hit start, this should go low. And it does. So the LED is now lit. When I serve, it should go back to high. And it does. Okay, and now it's back to, the LED's back on because the ball went away. So we serve again, they go high. Okay, the ball goes away, the light's back on. So that's working good. Now we're going to do, I'm going to restart the thing. Okay. Now we're going to do the start one lamp, which is 6. It's right there. This thing should go high when I put a coin in. And I don't know if that's enough to light the lamp. I really don't know. Now let's try the 2. I put another coin in. This one should go high. And I guess that, you see how it moved? I guess that's all it needs to do to light the lamp. I guess. So, I don't know, guys. That's what I'm thinking. But it did do something. Now I start a game, it should go low. So the lamps seem to work. The LEDs work. This thing's good to go. The paddle shares circuitry, so don't have to worry about that. Very well. Very nice. That's it. That's it for the lamp testing. Now we'll do a play test. I'm going to restart the thing just for good measure. Okay, I'm going to turn this off and remove this guy. Alright. And I had the logic probe hooked up too. I didn't need that hooked up. Okay. Now let me set this camera up and we will record. And we are ready to test. Let's go ahead and coin up. Hit start and serve. And try to get to that 100-point mark to get the free game. It's going to get really fast if it hits a 5-point ball. And we're back to slow, which is nice. Slow it down. This is addictingly fun. This is hard. It's not an easy game. There, 5-point ball. Let's break through. Let's break out. Nice. Nice. Uh-oh. Dang, come on. 10 more points, we get a free guy. Free game. Damn it. One more. Yes, here it comes. That is a signal for a free game. Awesome. That is it, guys. This board is complete. Working 100%. Working perfectly. It is going to require a modification to his cabinet. All it is putting in a switching power supply. It's not a big deal. And it'll be better for this board anyway, because it's got that burnt up, that burnt up nonsense on it. But this thing is now working 100%. We are finally done with Breakout. We're done with it. This has been a blast, though. I've had a lot of fun with this. Every IC on this has been replaced. Every chip has been replaced, believe it or not. Wow. Yeah. You know what I do want to do before we say goodbye to this? This is for a cocktail table game. I want to make sure that cocktail table works and the thing flips. I'm going to turn it off. I'm going to set the switch to cocktail table. And I'm going to put my lead on 2-player start, which is 15. It's 2 down from the regular one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, it's right there. I'm going to fire it back up. And we're just going to make sure that this thing, the table flips. I'm going to put 2 coins in. I'm going to do 2-player start. Here's 1 player. Serve. And let's just die. 2-player coming up. There it is. I don't have paddle. I don't have 2-player paddle hooked up. But it is a shared serve button. There it goes. Works like a charm, guys. And I'm going to turn it off, put it back on regular. No, I'm going to leave it right there. This is going in a cocktail table, so we're going to leave it right on cocktail for him. This thing is good to go. Guys, I appreciate you enjoying the series and sticking it out with me. But we got this thing going. It's going now 100%. Breakout. I could play this. I could play this all day, I think. I enjoy this. Simple, a little simplicity, but extremely challenging. Especially if you do a breakout. If you break out and you get the ball up top, your paddle is no bigger than the ball almost. It's like not even fair. Serve. I don't know if the camera's catching it, but this monitor is just glowing. The glow trail is awesome looking on the ball and the paddle. Hate these ones with the weird angle. We're going to get to 100 again, I think. Ooh. Them 5-point balls, that speed is crazy. Here it comes. Dang it. It's so hard. Alright guys, we're going to call it good. Appreciate you watching. See you on the next. Turn that light on. Just take a look at this board, man. This thing is pretty cool. Every chip has been replaced. And I had to make my own little custom adapters for those 9312 chips. Alright. Thanks a lot, guys. We'll see you on the next. Thanks for watching.